Okay, this is 4.8, calculate the area of irregular polygons. Now notice that we've got the word irregular here. We're still talking about polygons, but instead of regular where all sides are the same, irregular implies that the length of the sides of the polygon are not the same. Okay, for example, we have a shape down here. We have 1, 2, 3, 4 sides. Okay, just like similar to that square, it had 4 sides, but you'll notice that the lengths are all different. So how would we find the area of this one? Well, before we do that, let's do some of these, try these, okay? 1/2 times 18 plus 40. Now you have to remember your order of operations that you learned from junior high, BEDMAS. I'll just write that acronym right here, BEDMAS. You've probably heard it before. B stands for brackets. This is the order that we have to do the calculations in. B for brackets, E for exponents, D for division, M for multiplication, A for addition, S for subtraction. That's the order. So when we're doing number 1 right here, 1/2 times 18 plus 40, we have to do the multiplication first before we can do the division. So the first thing we need to do is do the 1/2 times 18, okay, or 0.5. 1/2 is 0.5. 0.5 times 18 equals 9, and then we add 40 to that, order of operations, and we get an answer of 49. Okay, really important that we do it in the correct order. Number 2, 3.1 times 3.4 divided by 2. Okay, we do the multiplication first, and then the division. Okay, so we get, or the brackets, 3.1 times 3.4 is in brackets. B is for brackets, so we always do what's in brackets first. So 3.1 times 3.4, we hit equals, and then we take that answer and we divide it by 2, and we can answer 5.27. Okay, so you can see that order of operations is really important when we're doing these calculations. Okay, so to do this 4.8, you're going to need a ruler, probably some paper, and a right triangle. Okay, so let's do this example here. Katie designed an irregular 4-sided patch of fabric to sew on her jeans. She divided the quadrilateral, okay, quad meaning 4, okay, into triangles to make it easier to calculate the area. Then she drew the height of each triangle using a right triangle to make sure that the height was perpendicular to the base. We need to know what the word perpendicular means. That means 90 degrees to the base. What is the area of the patch? So you can see that by just connecting this corner here with that corner there, she formed a triangle, and then what was left over, and then she drew that with a line, and then what was left over was another triangle. So she took this quadrilateral, all 4 sides are different shapes, and she made 2 triangles out of it. We know from 4.7 how to calculate the area of a triangle. All we need to know is the height of the triangle, which is this part right here, 90 degrees, and the height of this triangle B, which is 90 degrees, and we just need to know the base length. Now these 2 triangles just happen to share the same base length, which is quite convenient for us, makes it easier for us to calculate. So what are we going to do? We're going to calculate that area. You're going to take your ruler, and you're going to measure with your ruler the dimensions on these 2 triangles A and B. Okay, so number 1, what are the measurements of the 2 triangles? Well, I've already done this in advance. I've taken my ruler. Triangle A, the base is 65 centimeters, and since A and B share the same base, both are 65. The only difference is the height. So the height for triangle A, I measured at 1.8, so the measurements are in centimeters. I measured it in millimeters, so it's 6.5 centimeters. And the height for triangle B is 5.0 centimeters. Okay? So we need to calculate the area. Well, we know that the area for a triangle is base times height divided by 2. That's the area of a triangle. Okay? So I'm going to take these measurements here, I'm going to plug them into my calculator. Okay, so for triangle A, the base is 6.5. Multiply that by the height, which is 1.8, and I hit equals, and then I'm going to divide that by 2, and I get the area of triangle A is 5.85 centimeters squared. Triangle B, it's going to be a little bit bigger. I have 6.5 centimeters. I'm going to multiply that by 5.0, and then I'm going to divide that by 2, and I get an area of 16.25. 16.25 centimeters squared. Okay, so what is the area of the patch to the nearest tenth? Well, the area of the patch is just equal to the area of triangle A plus the area of triangle B, which is 5.85 plus 16.25. Notice that my answers are to the nearest 100th. I don't want to round to the nearest tenth until I add them together and get my answer, final answer. In the last step, then I round. So I'm going to add those numbers together. So I have 16.25 already in my calculator. I'm going to add 5.85 to that. I get an answer of 22.1. Well, that was easy. It's already rounded to the nearest tenth. So 22.1 centimeters squared is the area for that irregular quadrilateral, irregular polygon, that quadrilateral. Okay, example. Does Katie's method work with a 5-sided patch? Okay, so the only way we can figure it out is if we draw a shape that has 5 sides, and if we look at this reflecting hint here, if we can divide it into triangles, we can calculate it. So take a piece of paper, as it says here, and draw an irregular polygon with 5 sides. So I'll just kind of make one of my own here. There's one side, there's 2 sides, there's 3 sides, there's 4 sides, there's 5 sides. So I got a point here, a point here, a vertex here, a vertex here, and a vertex here. Now if I can connect these vertexes and form a triangle, form a series of triangles, I can calculate the area. So if I was to, let's say, connect that vertex with that vertex, I've got a triangle. I can find the height of the triangle right there. If I was to connect this vertex with this vertex over here, I've got a second triangle, and there's the height of the triangle right there. There's my 90-degree symbol, and you can see that I've got a triangle shape left over, and straight down 90 degrees, I've got another height there. So I end up with 3 triangles with a 5-sided figure. There's triangle A, there's triangle B, and there's triangle C. So can I do it? Draw as few triangles as possible to divide the shape. Well, with the 5-sided one, I found 3. Follow Katie's steps above. Does the method work? The answer is yes. You end up with 3 triangles. And all you need to do is just get the height with your triangle, okay? All right, with your right triangle over here. That one right there, you're going to need that from your teacher. You have a ruler, and then you can just measure it and do the simple calculations, okay? So go ahead and do the practice.